Dr. Williams is going to explain to us this morning why a classical education and approach to science and mathematics is preferable to the modern one, and he's going to give us some information about that. Dr. Williams is a professor at the Citadel in Charleston, and he is a guest instructor for us. So we have 2 required math and science courses as part of our AA, and so he's going to be covering those without having to give up his cushy job at the Citadel. So we're just really thankful for him. He is an atmospheric physicist with interest in geophysical fluid dynamics, atmospheric thermodynamics, and remote sensing. Currently, his research focuses on the physics of rotating convection systems such as hurricanes and tornadoes, and the dynamics of atmospheric boundary layers using computer modeling and remote sensing. Dr. Williams believes that the philosophical and historical approach to the sciences is the most valuable means of studying the world around us. He recognizes the necessity of the quadrivium, which is astronomy, arithmetic, geometry, and music, for the broader Christian worldview, and he strongly believes that science education should be integrated within the broader classical curriculum. He brings a wealth of knowledge on these topics, and he practices the classical pedagogy in his current position. He's the father of 2 young children who are here with him, and he is a committed advocate and pedagogue of classical education at the pre-college level. He is a tenure-track professor at the Citadel. He is a 6-day creationist with a proper understanding of the harmony between Scripture and science. He's a member of Christ Church in Mount Pleasant, and he and the pastor there, Dr. John Payne, have a podcast together entitled Between the Times. So, welcome, Dr. Williams.
All right, can you hear me in the back in terms of sound? Okay. So, morning, everyone. So the basic of this talk is really to give an understanding of how is it that the natural sciences, which today is probably the most important fields that people think of today, fits into the older model of classical education. Now, when most people think about classical education, what they're thinking of automatically would be the liberal arts, so grammar, logic, rhetoric. They're thinking of arithmetic, music, geometry, astronomy. And that means for a lot of people, what they're thinking is that there is an inherent bias towards the humanities and an inherent bias against the natural sciences. And so my main goal for today is just to kind of give 2 main points in terms of my emphasis. So the first is that the natural sciences are not a stranger to the classical model. I would say it naturally belongs within that classical curriculum, but it has to be in the proper place. And then the second part that I want to emphasize is that when we talk about the natural sciences, how we study it matters. So the proper study of the natural sciences can be greatly benefited if you use the tools that we know from the classical model and just apply that to the natural sciences. And then what I'm going to do at the end is kind of show you how this applies if you were, say, in a introductory physics, astronomy, or kind of a mathematics course. How does that actually work in a concrete way? Now, the way I'm going to kind of start this is a kind of going through the mentality of what classical education was historically when we look at the older universities. So that means we're going to first start with what the universities were back in the High Middle Ages, the 11th and 12th centuries. Now, there was a method of thinking that the Middle Ages produced, which is what caused the universities to come into being in the first place. And what I'm showing you here is a well-known sort of painting that existed from the 15th century from a Franciscan missionary called Diego Valadez. And this is a painting called The Great Chain of Being. And I think this is going to kind of give you an overview of how those in the Middle Ages viewed the connection between things that are on earth compared to things in heaven and how those things kind of come together in one whole. Now, this is actually a giant painting, so I'll kind of split this into two parts. So we're actually starting at the bottom of the painting, and we're going to work up to the top of the painting. So in this actual painting, we have 5 basic structures or hierarchies that exist. And so if you look at the very bottom down here, we are looking at basically inanimate objects. Think rocks, minerals, those sort of things. And when we think about those particular objects, they are not living because they don't have sense organs, they don't move, they don't reproduce, there's no nutrition involved. So we call them inanimate because they are not living in this case. And the idea is that this is the very bottom of the actual hierarchy because it is not life in itself or has life in any sense. But then what we do is that we start at the bottom and we're going to basically move up in this particular hierarchy. The next thing that you see in this picture at the very bottom here would be vegetation. Think trees, plants, and vegetative life. When we think of those things, we know that there is life in them because they grow, they reproduce, and they receive nutrition. But we will also say that plants do not have sense organs, so they are animates in that case, but they're not the highest order that you would have in this case. So they are above the actual inanimate sphere. Then if you look right above that, which is this region here, we have a whole bunch of animals here. Think of this as the animal kingdom that we would typically think of in an intro biology sort of class. What makes an animal distinct from vegetative life is the actual sense organs that are there. And so that means, unlike vegetative life, there is growth, nutrition, reproduction, but there's also sense organs that are present. So that means animals have a sensitive life. They can sense the environment that is around them. But then, if you go up even further, you get to the top portion of this particular picture here, which is mankind. Now, the reason that mankind is put in this particular location is because mankind shares things in common with things below, and it shares things in common with things above in that case. So, for example, mankind shares the ability to move. It has locomotion. They can grow. They can reproduce. They have sense organs. So there is a physical nature that they have. But we also know mankind is distinguished from the animals because mankind has what our confession says, a reasonable or rational soul. They have the faculty of reason, which distinguishes it from the animals and the things below in the hierarchy. Now, what I want you to see here, in the very center of this picture, there is a chain that goes from the bottom going all the way up here to the top, which means there is a connection between even the inanimate objects and what's going up the entire chart given here. And that chain goes all the way up into the heavens. And that gives you the angelic majesties. So think about the Apostle Paul in Colossians. Principalities, powers, thrones, dominions, all of those sort of things are in view here. And notice in this picture, we have some of the angelic majesties that are facing the actual glory of God. So think seraphim, cherubim, etc. And then we have some of the angels that you see here that are sent down as messengers to man in this case. Now, angels in this case are part of this great chain of being because notice that angels have something in common with mankind. They both have an actual rational, reasonable soul. But the difference is that angels do not have physical, corporeal bodies here. But there is a connection between the angels, mankind, and things that are even below all of that. But notice that the chain that starts at the very bottom extends all the way up here, which is depicting the throne of God itself. And here, think about what our confession says about who God is. He is infinite in being and perfection, a most pure spirit, without body, without parts, passions, immutable, immense, eternal, incomprehensible, almighty, most wise, most holy, most free, most absolute. He is distinct from the rest of creation, but notice all of creation gets its essence and its being from the actual God himself, extending downward in this picture. So the point I want you to see here is that in the medieval mind, God is not just an explanation for things we don't understand. He's not the God of the gaps. That's not the idea here. Rather, God is the one that gives meaning and being to everything below in the chain. So that means, for example, when we look at mankind, the animals, even inanimate objects, there is a connection between those lower beings and the being of God himself. So that's why what we say is that God, therefore, is the most absolute. And so now, think back to probably if you've done classical education, you've done logic, you probably remember that when we talk about God being the cause of things, we can think of that cause in four basic ways. Think Aristotle's fourfold causes at this point. Now, the first type of cause that we talk about would be a material cause. Think what something is made out of. When God made creation, he had no material that was originally there, so he had to produce and create that. In science terms, that means he's creating matter, he's creating energy, and therefore he is the essence and reason why inanimate things exist, rocks, minerals, and things of that nature. But it's not just the material that matters. We also have what is called a formal cause. How is the thing arranged? What is the actual arrangement and form by which something exists? So, for example, a dog and a tree are different, even though they're composed of atoms and molecules. What makes them different is that God has imposed a form on them, animals that are different than, say, plant life and other things. We also have what is called an efficient cause. Who or what actually made it, in this sense. And what we are referring to in this particular concept would be, what is the agent through which everything came into being? And this is Colossians chapter 1. All things were made by him, but then we have what is called the final cause that has everything included within it. The final cause is the basic reason why it happens. So Colossians chapter 1 says it this way: all things were made by him, and all things were made for him, Christ himself. We actually have a efficient, but we also have a grand overarching final cause of why anything at all exists. So the logic here is that if I wanted to study the actual world that I live in, I can't just talk about what it's made out of. I can't just talk about how the actual molecules and things are arranged. I just can't talk about the actual agent through which it comes. I have to talk about why it actually exists. Why is it there even to begin with? And that's why I have the final cause as being kind of on top here, because it explains why everything else down here even happens in this case. The other point is that the final cause idea that you see here is what we call the idea of teleology, the goal or the aim by which something happens. So the logic would be, if there is a final cause that is known, that means we have to understand what that cause is if we're going to really understand everything below in this sort of region here. And this is why in the medieval mind, it would be nonsensical to talk about matter, to talk about people, to talk about creation. It would be nonsensical to do that unless you're actually talking about the God who made it and made it exist for a particular reason. So one of the kind of analogies that people often have to kind of conceptualize this is to think of a solar system. So in this case, in terms of an analogy, think of the sun at the center here as being the being of God that keeps everything in its proper orbit and in its proper sphere. Now, in physics, what would happen is if I took the sun out of this picture, everything's just going to fly apart into random different directions, and no longer do you have a coherent whole and a completely gathered together sort of concept here. But the same thing is true when it comes to human knowledge and it comes to all of our understanding of the world. Without the actual concept of God, without the metaphysics and theology at the center, there was nothing keeping all the other fields of study like sociology, psychology, natural sciences. None of those things are even coherent anymore if you remove the actual center, which is our understanding of God and the philosophy that extends from him. So that's why in the medieval mind, the first thing that you would actually discuss is not the lower beings at the bottom of the actual chain. You would discuss what is the final cause first, because the final cause gives everything going down from there. Now, the reason I set this up is because this is actually how we put natural sciences and human knowledge within this actual chain of being. So I'm going to kind of go through the same exact picture. So remember, at the very bottom, I have rocks and minerals and a whole bunch of things that are not alive. Now think about the fields of study that examine rocks, minerals, matter, and energy. You're talking about geology and chemistry and physics and things of that nature. That would be what's being studied at this bottom level down here. That is the object of study in particular. Now notice that what comes above that would be what you have here in terms of vegetation and plant life. That is what we would call today biology. Think biology, botany, ecology, all of those particular fields of study. Now here's the basic kind of idea. We know that every single plant, every single vegetative object consists of inanimate things within it. So that means if I want to study biology in some way, I have to know something about the materials that make up that particular object. So that's why if you go to a standard college course, I can't really understand biology unless I first understand chemistry. And that's why there is a field of biochemistry, because I need to understand the chemistry before I can really understand the biology. But there's also a second point here that's relevant. Just like I need to understand something about the inanimate sphere at the bottom, plant life and animal life, they're not just a bunch of atoms coming together. There is something above animals and plants that give it its form and give it its structure. This is why chemistry and biology are not the same field. They have different laws, they have different ideas, and therefore they are separate sort of concepts here. Now, my point is the same kind of analogy just used down here with plants, animals, and things below it also applies to mankind. Think about mankind as a composite body and soul creature. It makes sense that the body is going to be composed of sense organs. It's going to have all of the standard things that you see in that inanimate sphere below it. So to understand man, you need to understand something about his physical body. You need to understand something about how his organs work. You need to understand how he interacts with his environment. All of that is related to things below mankind in terms of the chain of being. So understanding natural sciences is necessary for understanding what man is, because man has a true, actual body. But what I also would say would be the following point. I would also say that it is insufficient to just use natural sciences to understand man. So just like I need to understand something about the body to understand mankind, I need to understand something about his soul to understand man. So the natural sciences are necessary, but they are not sufficient. Something else is actually needed. Now, some of you may know the etymology of this, but there used to be a field called the study of human souls. That is what we used to call psychology a long time ago. Psychology was the study of the soul of man, which is why it was not the same as biology, it was not the same as chemistry, it was not the same as physics. It's a different idea because the soul of man is not the same as the body of man. So that means I need to understand how man interacts with his surroundings through his body, but I need something more to understand about the nature of mankind. I need to understand his soul. So this is why I would say there is a natural fit for the sciences. I need to understand the lower spheres before I can understand the upper spheres. But the upper spheres themselves also give me information about who man is. So when I talk about, for example, investigating the world around you, think about what that means fully. To investigate the world not only just means investigating the society that you live in, it also means understanding how does man interact with nature around him? How does man actually see himself in relation to the rest of creation? How does man exercise his particular role and task as the crown of creation? That is part of man's understanding of the world. So therefore, you need to understand how that actual relationship works. But again, this will be a natural science question. If I want to ask, how does mankind interact with one another, I am not doing, in this case, biology and chemistry. I'm now doing all of the human sciences. So think about the differences between what we call the liberal arts, in which we understand man's motivations, man's interactions with the rest of creation. Compare that to what it means to study the natural world. Both are necessary, but they are distinct, different fields. So that means when you put that together, if you really believe that mankind is body and soul, you can't neglect either one. You have to study his body and his relationship to the world, but you also have to study his soul as well. And that's why traditionally, when you looked at kind of the original physical scientists, say in the pre-modern age, like Isaac Newton and those of that same era, they never would have thought that the physical sciences were this completely isolated field compared to the rest of knowledge. They were integrated as one solid whole. That was the medieval mind kind of put together. Mankind truly is body and soul. Therefore, you need both the natural sciences and higher sciences to understand him properly. That's why I say the natural sciences complement. They don't replace the liberal arts. They don't supersede the liberal arts, but they come together to complement them. And that's one of the reasons why it was never a controversy to study the natural world within the original classical mindset. Now, that being the case, that was the older world, and what we know today is that that entire view of man has basically been rejected. And if you kind of follow popular scientists or listen to the New Atheists or something like that, you will hear a very popular mythology that has come about. So here's that popular mythology. First, the idea was that the scientific revolution was what basically got rid of everything that went on in the pre-modern era. So the logic was, when the scientific revolution happened, people like Copernicus and Galileo and Kepler, their discoveries basically took away the fact that the earth was at the center of everything. And the logic here was, if the earth is not the center, therefore the earth is completely insignificant. And that was how the modern mind interpreted. Now, some of you who are probably older probably remember there was a series of shows in the 1970s and 80s that Carl Sagan did. And he always had this basic statement when he starts his show, that we are nothing but stardust. That was his view, because in his mind, if I'm only stardust, that means I don't have a soul, there's no final cause, and that means I am just an insignificant speck in the cosmic vacuum that exists. That was what people popularly kind of started saying when we came into the 20th century. So the first thing that people said was that the scientific revolution transformed how we viewed the world. And then some of you have probably read this before. Think about the work of Charles Darwin and Freud and all of the various 19th and 20th century psychologists and biologists. Their argument is, not only is man insignificant, he doesn't even have a soul. He's just a complete body with unreasonable, irrational passions. So in the medieval mind, mankind was kind of a microcosm. He stood between the angels above and the actual earth below, in a sense. And therefore, he was considered the crown of creation. In Darwin and others' mind, mankind is no different than any animal because we all have the same basic ancestor. That primordial slime and ooze that came out some billions of years ago. That is how the natural sciences are taught today. And notice that what that really means is that if there's no soul, if it's just a body, that means there's nothing that connects mankind to what's above him. And that means if you reject the actual soul of man, you end up with a situation where there's no longer a final cause that brings order and coherence to everything else. So in other words, what people would say is, we don't really live in an ordered cosmos. We live in a vacuum with nothing there, and that is the standard way that this will be taught at a typical evolutionary biology class. Now, probably for most people, the most famous statement of that idea is Richard Dawkins. You've probably seen this quote before, where he is arguing that rejection of final causes. And he says, the universe we observe has precisely the properties we would expect if there is at bottom no design, no purpose, no evil, no good, nothing but blind, pitiless indifference. That is the result of rejecting all of that classical thought. That's your final conclusion. And that is why the modern scientific approach has all of these other philosophical problems tied to it. Now, put that together, if there is no good, no design, no purpose, where do we get all of this order from? How does modern science explain the order of creation? And this is a popular figure that you can pull from an introductory biology book. And this is what is typically called the hierarchy of the sciences. And so the logic of this diagram is there's nothing on top that orders anything. Everything starts at the bottom and just builds up naturally. So the logic of today would be everything comes back to mathematics and physics. If we find out the unified theory of creation or the unified theory of physics, if you find out the last particular standard particle model, if you pull all that stuff together, we will understand everything. That's the drive that a lot of people have. Then the logic is, if I understand physics, I will understand biology and chemistry. Because in their mind, there is no difference between physics, the inanimate objects, and the rest of creation. But there's something else more important. Remember I said earlier that psychology was thought to be the study of the human soul. Now, what's psychology today? It's the study of the brain. It's neuroscience. Why do they come to that conclusion? Because basically, there's no soul to even look at. Everything that happens in the modern mind is based upon neurons firing in the brain. So psychology is no longer a study of human souls and its relation to others. It's now just a whole bunch of neurons, and we got to figure out why those neurons fire the way they do. That's why there is a social science movement today, because we believe that the societal influences that we have are just purely biological. If we can figure out the biology, we can therefore figure out everything else. So the conclusion that the modern scientific approach says will be the following. If we reject any sort of final cause, if there is no God that orders everything below, that means the only way that you will get order is from the particles coming up. So notice there's a difference in the path. In the medieval mind, order is from God going down in a chain of being. In a modern mind, order is from the particles that make up things, and they come together in a mysterious way to give you order, structure, and coherence. So for the modern mind, order, coherence, and a study of sciences is really going to be a study of what's going on at the bottom, physics and chemistry and biology. That's where modern science is today, and that's the result of hundreds of years of chipping away at the foundations when it comes to why we even study natural sciences to begin with. Now, there is a big push, and I'm sure you haven't seen this at this point. There is a big push to replace the actual medieval mind completely. So there was what was called a great chain of being from God going down. If you go to, say, Huffington Post or a number of European research agencies, they say we have what is called a great matrix of being. They're trying to borrow the same idea, but they don't have an ordering principle. So in their mind, what brings everything together is essentially going to be 14 billion years of gradual evolution, 5 billion years of Earth's evolution, 1 billion years when it comes to animal and sensitive life on the planet, 1 million years of human development, and then they have this giant quantum leap. Apparently 10,000 years ago, mankind accelerated its development so that we now have civilization. Notice in their mind, everything started at the 5 billion, 14 billion year of just particles in a vacuum. Somehow over 14 billion years, you build that all the way up to some rapid acceleration of human civilization. This is now called the Big History Project. This is actually a push in terms of the framework by which to view human knowledge. Again, instead of having a top-down organization, we now have this bottom-up organization in the natural sciences. So when we put all of those things together, this is an understandable reason why most people who do classical education would say the modern scientific approach is completely incompatible with what we think about basically the natural sciences and the real world. But my argument here is what the classical approach does is that it actually gives us a way to critique this really well and actually to build on something that's substantial. So I'm going to give 2 quotes from someone who has done the same sort of work and analyzing the modern science assumptions and look at kind of the incompleteness of the modern approach. So first, we're going to look at the positive side. And this comes from the author Christopher Bloom from a research institute called the Augustine Institute. So it's no surprise what his viewpoint is. This is the positive side. And he says, modern science looks upward with wonder and awe, and with a thoughtful puzzlement ponders the seemingly inexhaustible order and intelligibility of the cosmos, day by day, unfolded in laboratory, classroom, field station, and observatory. This is what he views as the positive side. But really, what this is saying is the modern scientist is driven by something that they cannot adequately explain. For example, in the modern approach, why would you have order and intelligibility? Why would that even exist? Will be the first question. And the second question is, isn't it odd that only mankind understands the cosmos really well? Why doesn't the lower creatures understand mankind, understand creation and the cosmos? But that's an open sort of given statement from the modern science approach. So that will be the positive end. So now I have a much longer quote on the negative side of this, which says the following. This is the face, meaning the modern science, this is the face that rejects the search for the first cause. Think final cause here. Insists that science attends only to what its instruments reveal, but not as a wise and humble matter of practice, but rather as a dogmatic injunction. For it holds to be real only those things revealed by its instruments. This is the science that refutes itself by suggesting that all things in nature and human affairs are determined by material causes alone, that these causes themselves are radically unintelligible, because again, why would these even happen if it's random? Because they work only by probabilities and chances. And though it does not trumpet the embarrassing claim loudly, it must ultimately admit what its principles declare. And this is the big critique of the modern approach. If everything is probability, then does man actually know anything? Is man actually a knower? Or is he just someone who tinkers in a lab and gets things for mysterious, unknowable reasons? So the real critique of the modern approach is that if you reject the existence of a final ordering cause and base everything upon probabilities and likelihoods and chance, that means you're saying man doesn't truly know what he knows. He's just tinkering around, getting things that happen to look like order and patterns. That is what the major critique is of the actual classical, of the modern approach. And now we're going to bring this into today. How does the actual natural sciences, from a classical viewpoint, address these issues? First thing I'll say is, think about elementary school, where you spent time looking at nature all around you. And when you walked outside and you examined nature, you didn't just see random unexplained patterns or random unexplained phenomenon. You saw things that were beautifully crafted, beautifully harnessed, and well ordered. And it's not just true for the things man itself makes. So let me give you some visual examples. Think about a honeycomb. Why does a honeycomb have such exquisite geometric patterns situated on it? Those are all perfectly constructed hexagons that you will learn in a geometry class. Why does that exist is a really fascinating question, but it's something you would learn if you just went to see a beehive. Look at the patterns that are there. They're obviously not random in that case. Here's another example. Think about a seashell. Think about the actual form that that seashell has. And so one of the things I always ask students would be, if you look at a seashell, you see a spiral pattern, and it turns out the spiral pattern is exactly the same as the spiral pattern in a storm. It's also the same spiral pattern in a galaxy. Why do these consistent patterns reappear? Now, there's a whole bunch of other sort of examples as well visually. So, for example, when we look at what are called ferns, and what we can do is to look at the actual structure of their leaves. If we were to zoom in a microscope and examine it, we see that there is detailed structure at very, very, very small levels. So you have the actual structure of the whole leaf, but then when we look at a particular branch of that leaf, it has its own unique total structure. That's what we call a fractal pattern. Lots of structure at really, really small levels. Where does that come from? And likewise, look at plants that have this great symmetry that exists around us. This used to be what constituted an older form of education. Look at actual nature around you and figure out what you ought to deduce from it. So nature itself is full of these geometric patterns. For us, the reason we can explain this is because we know that there is form that actually gives the structure to matter. It's not just a bunch of molecules. There's a form imposed downward in this case. The same thing is true when we look at geometry when it comes to motion. So in mathematics, we have a field called analytic geometry. And it means taking geometry and applying it to points in coordinate systems. So taking trigonometry and applying it to geometry here. Now, this is actually something that's important historically. When scientists were originally studying nature, they were looking at geometric patterns and seeing how they fit. So, for example, when I throw an object into the air, like a tennis ball, it has a very specific shape. In geometry, that is a parabola. It's a well-defined geometric object. Or, for example, when we study the solar system, that's not a random orbit. That is a well-defined geometric shape called an ellipse. They have real concrete structure. But then in the 20th century, we have things like the theory of relativity, where objects themselves are beginning to bend and distort time and space around it. That's a geometry problem. Just think of bending a sheet of paper and looking at the shape it actually has. Again, there are geometric patterns all over nature. And those geometric patterns are not from the bottom up. They are coming from something above its particular design. Another example would be in chemistry. When chemists study, for example, different types of molecules, they go back to geometry. They study the geometric structure of molecules and figure out their properties from their geometric structure. So the point is, the natural sciences are actually just extending what we commonly do in geometry. We just apply it to a very specific field. So think about what you learn in classical education. You learn geometry in a lot of detail. Now we can apply it to things in nature because those patterns are not accidental. There's order that is actually embedded in there. And that means when it comes to natural sciences are not just an isolated field on its own. Natural sciences is integrated within the rest of what we know. So you can't really understand much of the natural sciences without actually going through understanding the geometry and the math tied to it. So that means, for example, when I study the solar system itself, I have to understand something about the math and geometry here, but there's also something else true. I can't really understand the theory of this actual picture unless I understand what was the philosophical and historical beliefs of the people who suggested this, like Copernicus and Galileo. Their philosophical beliefs are actually tied to why we have a particular solar system model here. So again, natural sciences and history and philosophy are integrated together. They're not separate, they're held together by a common cause. Now, the final point here to kind of say is that one of the things I do in the classroom is I say, when you look at the classical approach, one of the things that we care about in detail is how do we actually teach science well? And some of you had to take these general education science courses in college, and you remember how terrible that went personally. You remember the various sorts of charts and figures that were just kind of thrown at you with no sort of content really tied to it. The opposite of that is what we call mastery learning, which means we're not just trying to throw facts at you just so you can kind of build up this huge reservoir of factual knowledge. We're really trying to get you to understand the essentials. We push away the tangential, unnecessary topics, and we focus upon the essentials themselves. So that means what this means for us is when we teach this, we are always cycling back and forth and reviewing. So think about this when you, for instance, you learn Latin. You never just take Latin, basically learn your basic conjugations, move on, learn something else. You always spiral back around on previous topics. Science should be taught basically the same way. We don't just isolate it, we combine it together. It also means we have to have a systematic way to hold you accountable. This is why in the classical model, we give oral exams and recitations. You actually have to stand up and defend an argument. You actually have to describe a physical process and explain what's going on. You don't really do that in other colleges and other sort of pedagogies here. And then the last thing we do is that we always take the skills that we learn and we always build this from basic to complex. We always go back to the basics, build the new skill. Back to the basics, build the new skill. And that means you have a spiral type of approach. Now, if you're honest, when you came to classes you didn't care about in college, you did a very different model. What you did was that you crammed, you passed your exams, and you forgot it 2 weeks later. That's probably what happened to you, right? Think about your freshman level biology or chemistry course. How much of that stuff do you still remember? Probably not that much. Why? Because you weren't really asked to master it. You were just asked to jump through the hoops and to pass the actual classes. So to learn science well means that you have to resist the temptation of throwing all of this stuff at people, and you have to really harness in at the central goals. Now, how does this actually apply, let's say, to a college class? So let's suppose I was teaching an astronomy class, and this is like a general education class. Now, what I would do is that I would split this basically into 4 basic parts. And this is based upon the most important concepts in an introductory astronomy course. So the first is, how do you observe the sky? you'll be surprised how many people cannot point out constellations, or how many people can't point out Venus or the other visible planets. Instead of skipping that and just moving on, that is a major component of your class, looking up and seeing what's there. The next is going to be historical and philosophical. Why did people believe in a geocentric view of the universe? It's not just because they didn't have any idea what they were talking about. There was actually an argument that they were building for hundreds to thousands of years. There's a reason that geocentrism was a prevailing view. Then we have what happened in the 16th century. Why did that model get rejected and replaced? So that is something that you have to understand if you want to understand astronomy. How that happens is a very important part of what we do. And then finally, if I wanted to talk about the 20th century is the century where we learn what is called cosmology, the large-scale structure of the cosmos. Think Big Bang Theory, for those of you who've heard that before. Now, in a classical class, the goal is not just to use a random textbook that has only secondary sources. Our goal is to basically go to the original sources, go back to the primary. So, for example, when we look at identifying constellations and planets, there are star and planet catalogs that have already done that. So how can we retrace their steps? That is an essential skill for even amateur astronomers at this point. How do we measure where these things are located? How do we know, for example, that stars are outside of our solar system? How do we know that basic fact? That is part of what we actually learn in a standard intro class, so understanding where these measurements come from. And also, think of something as basic as the phases of the moon. So right now, if you were to look into the sky, could you predict where the sun, the moon, and the earth are located just based upon the view of the moon and the time of day that you see it? That was what ancient Babylonians, Egyptians, and all ancient societies did. That's a pretty basic skill and a very useful skill to get out of a particular class. When it comes to the geocentric model, my approach is go back to what they read. Go back to what was being debated. So, for example, you can actually read Aristotle's book on how he defended the geocentric model. And it's not a complex book. It's a little bit long, but it's not complex. That means you can understand what Aristotle was getting at. We also have the same thing for Ptolemy. He was the one who crafted the prevailing sort of model for the solar system, what is called the Almagest. He actually showed his measurements, showed why he changed his particular views, and showed how he pieced together his particular model. And then we have a book that is similar to the other two called The Reckoning of Time. So we can take selections out of these books and actually discuss them as a recitation. What are they arguing? Why are they arguing for geocentrism? And what's the implications? So this is recitation. We are sitting and we're talking. We're actually looking at what they argued and going from there to understand where they're going. So the idea is you're obviously going to disagree with what they said, but you now understand why they said it. That's the actual point here. Just like you have books that defended geocentrism, we have texts that do the same thing for the heliocentric model. So, for example, there are passages out of Galileo's Starry Messenger. Now, you probably have heard lots of misinformation. You've heard lots of falsehoods about Galileo and his work, probably, from other people. You can go directly to his actual book and find out what was his actual contention. What was he actually arguing? And why did he actually stand really firm on the heliocentric solar system model? We have the same thing for Kepler. Why did Kepler spend 30 years of his life getting observations? It's because he was convinced of what Copernicus did before. So we can look at selections from that book as well. And then probably the most important book from all of those things would be Newton's book on planetary motion, what is called commonly the Principia. this is where he talks about his theory of gravity. So notice, we can go to their sources, and that's the idea that we have in mind here. And the final conclusion would be, you should be able to defend where that argument came from in a recitation. So that means I take two students, and you have them debate geocentrism versus heliocentrism. Have them talk through the arguments. You can piece holes in logic. You can piece holes in inductive reasoning, and have them actually go towards mastery. And then finally, we can understand what was the consequences of Newton's victory. And there are all sorts of books about this. And so one of the ones that I always pull from in terms of a chapter or two is a book called The Metaphysical Foundations of Modern Science. This is a book that tells me what was Newton's philosophy that led to his theory of gravity. And it basically talks about that in a good amount of detail. From there, you can understand what happens centuries later, because there's a connection there. And then we end that particular course by looking at what happened in the 20th century. Now, you're probably not aware of this in other cases, but there were large debates in the 19th and 20th century about the size of the actual universe. And there are lots of people who talked about these things. One of them is named Vesto Slipher. He is the one who saw that there were large gas clouds called nebulae that existed outside of the solar system. We have a radio debate that happened between two astronomers debating on whether or not the galaxy is large or small. That happened basically in the 1900s before the Scopes trials in biology. You probably know the Scopes trial. You probably don't remember this one given here. We also have Edwin Hubble. He is the one who basically suggested that the universe is expanding. Why did he get that particular conclusion? And then probably the most famous of the 20th century people was Lemaitre, because he is the Roman Catholic priest who produced the Big Bang Theory originally, which became the foundation for 21st century astronomy. So the point is, I'm not doing large numbers of topics. I'm doing some topics in larger depth, because the goal is for you to seek mastery and understanding. It's not just to give you everything about stars and planets and galaxies and galaxy clusters. Very, very specific sort of things. So I'll end my talk here by just thinking about what this means when it comes to an actual person understanding the world around them. Think about what we read in Psalm 8, Psalm of David. Think about this in terms of this chain of being that we cared about. So when I consider your heavens, the work of your fingers, the moon and the stars which you have ordained. So again, here is someone contemplating why there is order. Thus, he raises the question, what is man that you take thought of him? And the son of man that you care for him? So why is mankind considered important in view of the glorious sense of the cosmos? And then David comes to this conclusion, you have made him a little lower than the heavenly beings. You have crowned him with glory and majesty. So again, man is a microcosm. He has glory beyond the creatures because he is connected to that chain of being. You make him to rule over the works of your hands. You have put all things under his feet, all sheep and oxen, all beasts of the field. Think of everything below mankind at that point. The birds of the heavens and the fish of the sea, whatever passes through the paths of the seas. When we study natural sciences, we're doing, in a sense, in a much more modern sense, the sort of contemplation that David is doing in Psalm 8. We are examining the world around us. We are asking real questions about why this exists and why it actually happens. We're understanding final causes beyond just the material cause itself. And so our consequences of all these things is that it leads us to the wonder and awe that we all should have when we study God's world. So I'll end there.